Good morning all, my name is B. Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is Digital Image Processing. Today I am discussing about restoration in the presence of noise only, spatial filtering. So before going to this spatial filtering, what are the restorations and what are the process of restorations in the presence of noise, we will discuss. So the restoration in the presence of noise only, spatial filtering. So that means the image restoration is performed by reversing the process that blurred the image, and such is performed by imaging a point source and use the point source image, which is called the point spread function, PSF, to restore the image information lost the blurrings process. When the only degradation present in an image is noise, that is using the pixels in the region defined by SXY. So this operation can be using convolution mask in which all coefficients have the value of 1 by mn. So what is the image restoration? We have to first discuss what is the restoration in the presence of noise, and then we will discuss in the how it is a major role in the spatial filtering. We will discuss. So image restoration is performed by reversing the process that blurred the image, and such is performed by imaging a point source and use a point source image, which is called the point spread function, PSF, to restore the image information lost to the blurring process. So point spread function, PSF, is the major role to restore the image of the information, so which is lost in the blurring process, that is a noisy. So when the original image with the noise is called restoration in the presence of noise. Okay, suppose I have one image is there, that image is a noisy. So I am using some filters. Noiseless image is there. So noisy image, with the help of filters, I am converting to the noiseless image. Okay, so this noiseless image I am calling as a restoration of the original image. Suppose noisy image I am calling as a f of x, filters I am taking a w of x. Here noiseless image I am taking as a f dash of x. So f dash of x equal to f of x. Why? Because f dash of x is a noisy image and f of x is a noiseless image. Okay, this noiseless image is restored in the place of noisy image. That is the restoration in the presence of noise. So when the only degradation presence in an image is noisy, that is g of x comma y equal to f of x comma y plus nu of x comma y, or capital G of u comma v is equal to f of u comma v plus n of u comma v. Here g of x comma y is equal to output image, f of x comma y equal to input image, so nu of x comma y is equal to noise image, noise. So when input image plus noise, input image with noise, okay, that is a noisy image. So what is output? That is a noiseless image. So what we are using the means degradation processes are done. So what is a degradation process? When it is need means when input image with noisy, I have to converting to the noiseless. That is a degradation process. Okay, what is our final output means noiseless image. So that is my output. So what is the process we done means degradation process. So why we are done means noise is there. So I have to convert to the noiseless. That is the process. So the noise terms are unknown, and so subtracting them from g of x comma y or capital G of v comma v is not a realistic approach. In the case of periodic noise, it is possible to estimate n of u comma v from the spectrum g of u comma v. So n of u comma v can be subtracted from g of u comma v to obtain estimated original image. So what is the original image means? Noiseless image. So when the original image I am calling as a noiseless image, so n of u comma v can be subtracted from the g of u comma v to obtain the noiseless. So noiseless means noise plus input image converting to the noiseless image. Okay, that is the equation. So spatial filtering can be done when only additive noise is present. The following techniques can be used to reduce the noise effect. So restoration in the presence of noise means the noisy image converting to the noiseless image. So what is the technique here I'm using means spatial filtering technique I'm using. So spatial filtering can be done when only additive noise is present. What is the condition? I have the noise is there in the image, but what is the noise? Additive noise is present. Then only spatial filtering using for that images. So the following techniques can be used to reduce the noise effect. What is first one? Mean filter. Mean means arithmetic mean filter. Okay. So it is the simplest mean filter. Let S, X, Y represents the set of coordinates in the sub-image of size m into n. It is centered at point x, y. The arithmetic mean filter computes the average value of the corrupted image g of x, y in the area defined by S, X, Y. The value of the restored image f at any point x, y is the arithmetic mean computed. So here I am using mean filter to reduce the noise. Okay, in the mean, there are so many methods are there. First one is a arithmetic mean. So what is the arithmetic mean? It is the simplest mean filter. That is, the image S, X, Y represents the set of coordinates in the sub image of size m into n centered at point x, y. So the arithmetic mean filter computes the average value of the corrupted image g of x, y in the area defined by S, X, Y. The value of the restored image f at any point x, y is the arithmetic mean computed. So f dash of x, y, that means output image or noiseless image or output image f dash of x, y equal to 1 by mn into summation of s, t is summation s, x, y of g of s, t. So the final output value is equal to summation of the input image with noisy. Okay, that is the noiseless image. So using the pixels in the region defined by S, X, Y, this operation can be using a convolution mask in which all coefficients have the value 1 by mn. A mean filter smoothing local variations in an image noise is reduced as a result of blurring. So for every pixel in the image, the pixel value is replaced by the mean value of its neighboring pixel with a weight. This will result in a smooth effect in the image. So when the pixels in the region that defined by SXY. So it is the image with the pixels SXY. The operation can be using a convolution mask. Why I am using here mask? Mask is nothing but it is working as a filter. So when I am using the filters, mask is a mandatory. It is a technique in the place of mask, in the place of filter, in which all coefficients have the value. A mean filter smoothest local variations in image noise is reduced as a result of blurring. For every pixel in the image, the pixel value is replaced by the mean value of its neighboring pixels with a weight. So it will be resulted as a smoothing effect in the image filter. Another one is a geometric mean filter. In the previous we discussed arithmetic, now geometric mean filter. An image restored using a geometric mean filter is given by the expression. This filter is useful for filtering the darkest point in an image. Also, it reduces the salt noise of the main operation. So f dash of x comma y equal to, already we discussed, it is the output image or noiseless image. So the output image or noiseless image f dash of x comma y equal to pi of s comma t. It is the coordinates or pixels g of s comma t of 1 by m into n. So it is a formula for geometric mean filter. So what is the use means? We are finding out, or we are restored the original image and removing the filters. Removing the noises with the help of filters. So an image restored using a geometric mean filter is given by the expression. This filter is useful for flinging the darkest point in image. Also, it reduces the salt noise of the mean operation. So another one is a midpoint filter. Midpoint filter. So what is the use of midpoint filter? The midpoint filters simply computes the midpoint between the maximum and minimum values in the area accomplished by it. Combines the order statistics, the averaging. This filter works best for randomly distributed noise like Gaussian and uniform noise. So what is the advantage of midpoint filter to reducing the noise from the original image? Means it is the filter simply computes the midpoint between the maximum and minimum values in the area encompassed by its combines and the order statistics and averaging. Order statistics and averaging technique we are using to find out the noise. And this filter works best for randomly distributed noise like Gaussian or uniform noise. So Gaussian noise or uniform noise is occurred, then only we are using midpoint filter. So midpoint filter output f dash of x comma y equal to maximum of g of x comma t plus minimum of g of x comma t. So maximum plus minimum. It is also called maximum minima filter. Maximum minimum filter, also called midpoint filter. Why means it is the average of maximum and minimum. It is the average of maximum and minima. That is the midpoint filter. The midpoint filter is a one type of technique to reduce the noise. So what is the technique means? Average or order statistic, that is the maximum plus minimum by 2, average of maximum and minimum, that is the midpoint of the value, that is a midpoint filter. So another one is a harmonic mean filter. Harmonic mean filter. The harmonic mean filtering operation is given by the expression. The harmonic mean filter works well for salt noise. When the noise is in the salt noise, then only harmonic mean filter is using, but fails for pepper noise. For pepper noise, it is not used. Sometimes what will happening? Salt and pepper noise is there, but here we are dividing as a salt noise is different and pepper noise is different. So it will works for salt noise, not for pepper noise. So harmonic filter is using for salt noise, but not for the pepper noise. Okay, only the salt noise is occurred in the image, then only harmonic filter is using. Otherwise, we can't use. For the pepper noise, it is not used. So when salt and pepper noise is there, for this combination of this one, harmonic filter will be not used. Okay. So the harmonic mean filtering operation is given by the expression. The harmonic mean filters works well for salt noise, but fails for pepper noise. It does well with Gaussian noise and also f dash of x comma y equal to g of s comma t divided by summation of g of s comma t. Okay. So another one is a order statistic filter. So order statistic filters or spatial filters whose response is based on the ordering of the pixels contained in the image area accomplished by the filter. This response of the filter at any point is determined by the ranking of the result. Okay. Another one is a order statistic filter. So there are so many noises are there. For which type of noise we have to, which type of filter we have to use. So every noises we have the solution with the filters. Okay. There are different types of noises are there. For the different types of noises, we are using different types of filters we are using. Okay. So for all the noises, we are not using one filter. So different noises, we are using different types of filters. Okay. So order statistic filter is also one type of filter for the different applications of the noises. Okay. So it is a filters in spatial filters whose response is based on ordering the pixel contained in the image area accomplished by the filter. The response of the filter at any point is determined by the ranking result. So another one is a median filter. It is a best order statistic filter. It is a best order statistic filter. It replaces the value of the pixel by the median or gray level in the neighborhood of the pixel. So median filter is a best order statistic filter. Why I am calling it is a best means it replaces the value of the pixel by the median of gray level in the neighborhood of the pixel. That is the reason we are calling as it is the order statistic filter. So the original of the pixel, what is the original of the pixel? F of x, y is included in the computation of the median of the filter are quite possible because of the certain types of random noise that provide the excellent noise reduction capabilities with considerably less blurring than smoothing filters of the similar size. So suppose f of x, y is a noisy. Which type of noise? Some blurring. So blurring is also one type of noise. Okay. So when I'm using median filter, so what is the use of median filter means? We are reducing the noise. Which type of noise means? Image blurring or less blurring of the image. That is a smoothing filter with similar sizes. Okay. So these are effective for bipolar and unipolar impulse noises. And another one is a maxima and minima filter. Using the 100th percentile of the ranked set of numbers is called the maximum filter, and it is given by the equation. It is used for finding the brightness point of the image. Okay. Here I am using pepper noise. Here in the previous we discussed salt noise, but for the pepper noise we are using maxima and minimum filter. Maximum and minimum filter. So using the 100th percentile means last one 100th percentile of ranked set of numbers is called the maximum filter, and it is given by the equation. It is used for finding the brightest point, in an image. So pepper noise is in the image has very low values. It is reduced by maximum filtering using the maximum selection process in the sublimited area sky. The 0th percentile filter is minimum filter. That is the f dash of x, y is the output image is equal to minimum of g of s, t. So minimum of g of s, t. When we are using the noise or filters we are using, so f dash of x, equal to minimum value of with filters. Another one is a Gaussian noise. Okay, the PDF or Gaussian noise is given by P of z equal to 1 by square root of 2 pi sigma into e power minus of z minus mu whole square by 2 sigma square. So it is a Gaussian noise of PDF. So it I am taking x axis and the y axis. Okay. So in the x axis I am taking mu and sigma values. In the y axis I am taking the coordinates of the P of z. So where z is the gray value. Mu equal to mean, sigma is the standard deviation. Okay, it is a graphical representation of Gaussian noise. Salt and pepper noise. In the previous discussion, we discussed when salt and which type of filter is using for salt noise, which type of filter is using for pepper noise. Suppose example, maximum and minimum filter using for pepper noise. So So we are using filters for the noises. But what is the noise? Which type of noise is there? So when the image is occurs some noises, okay, what are the noises are there? What are the names we are calling for that noise? Okay. So a type of noise commonly seen in photographs is salt and pepper noise. Okay, a type of noise commonly seen in photographs. Okay, that is the salt and pepper noise. So they manifest as white and black pixels that appear at random intervals. Black and white with pixels, that is the salt and pepper noise. So salt and pepper noise, when you are calling salt and pepper means when the input image has the black and white with pixels. So change pixel values with black and white. So a white and black pixels that appear at random intervals. Errors in data transfer cause this form of noise to appear. The values A and B of the salt and pepper noise are different. Okay, when I'm taking A and B values, okay, so A is calling as a white or B is or a black. So that is a salt and pepper noises. The values of A and B in salt pepper noise are different values. Each has a probability of less than 0.1 in the average. So the corrected pixel means noise pixels. Okay, the noisy pixels are alternatively the minimum and highest value is giving the image as a salt and pepper. Okay, minimum and maximum. What is the minimum values and maximum values of the image? That is a salt and pepper noise. The use of a median filter, morphological filter or contra harmonic mean filter is an effective noise irradiation strategy for this type of noise. So in this situation, we have to improper switching of occurred in the salt and pepper noise. Then we have to use distribution of the pixel representation of the noise. Okay, so it is a gray level, x-axis and y-axis, gray level, and it is a probability of this one. So pixel representation of the noise. Okay, it is a noise image. So it is a noise with pixel representation. Well, how it is means white and black in form. So majority of blacks are there or majority of whites are there. So we have to find out. So I need majority of blacks. I need majority of whites. Okay. So we have to use, we are changing the salt and pepper values. So it is the impulse function or salt and pepper noises. Okay. It is the impulse noise PDF. I'm taking the salt and pepper PA, PB, and I'm changing the A and B values. It is the impulse with the probability. It is a probability value. Probability with impulse. Probability with impulse. That is a salt and pepper. So what are the characteristics of noises? Means noise digital impression arises during acquisition, environmental conditions, light level and sensor temperature, and types of cameras. Okay, if the camera fault is there also, it is type of noises are there. So generally spatial noise is assumed to be independent of position in an image and uncorrelated to the image itself. That is, there is no correlation between pixel values and the values of the noise component. The frequency properties refer to the frequency content of the noisy in the Fourier sense. So what are the noise models are there? In the spatial noise is described by the statistical behavior of the gray level values in the noise component of the degraded image. So when I'm using PDF means probability distribution function, that is noise can be modeled as a random variable with a specific probability distribution function, that is a PDF. Okay, in the PDF is a major role in the noise models. Okay, what are the parameters and what are the frequency properties? So the parameters of the noise models are spatial characteristics of noise, whether noise is correlated with the image, that is a parameter. And what are the frequency properties? So frequency content of the noise in the Fourier sense, when the Fourier spectrum of the noise is constant, the noise is usually called that the white noise. Okay, these are the parameters. So in that we discussed today restoration in the presence of noise only in the spatial filter, means how the noise is occurred in the image, which type of noises are occurred, and which type of filters we are using, and after the reducing the noise, that is called restoration with the original image. Okay, so in the noise image is there, so the noise image is there, that is the input image. So when I'm using the filter function, that is a degradation function. So after the degradation process, noiseless image is there, that is the f dash of x comma y. So f dash of x comma y equal to f of x comma y into g of x comma y. That is a degradation process. Okay. Otherwise, what is the degradation process equal to? F of x into nu of x. Means nu is a noise. Input image with noise is a g of x comma y. But f dash of x comma y equal to f of x comma y. That is the process. Okay. So image restoration is performed by reversing the process that blurred the image, and such is performed by imaging a point source and the use of point source imaging, which is called the point spread function PSF, to restore the image information lost the blurring of the image. It is a blurred process where the degradation present in the image is noise, that is using the pixels in the region, and the operation can be using to the convolution mask. Convolution mask means I am using filter here. Okay, g of x comma y equal to f of x comma y plus nu of x comma y, means degradation function g of x comma y. It is a degradation function is equal to f of x comma y, input with noise, input plus noise, that is a degradation process. Another one is a mean filter, that is a arithmetic mean filter. It is the simplest mean filter, that is a x comma y. G of x comma y is a degraded function. So f dash of x comma y equal to output function. It is a 1 by mn summation of g of s comma t. And geometric mean filter means output is equal to pi of g of s comma t. It is another expression in the form of geometric filter. It is a midpoint filter. So when I am using means when it is a averaging filter. Okay, and it computes the midpoint between the maximum and minimum values of the area. And the filters works with the randomly distributed noise like Gaussian and uniform noise. When the Gaussian and uniform noises are there, then I will use midpoint filter. And harmonic filter. When I am using harmonic means when the image with salt noise. When the image is not salt noise, then only we have to use harmonic mean filter. We can't use pepper noises. And Gaussian noise is also useful. Gaussian noise also occurred in the salt noise, then only using harmonic filter. Another one is a auto statistic filter, that is or spatial filters. It is also called spatial filters, whose response is based on ordering the pixel contained in the image area encompassed by the filter. The response of the filter at any point is determined by the ranking result. Another one is a median filter. It is a best order statistic, and it replaces the value of a pixel by the median of gray levels in the neighborhood of the pixel. The original of the pixel is included in the computation of the median filter of the filter, quite possible because of the certain types of random noises. So these are effective for bipolar and unipolar impulse noises. Another one is a maximum and minimum filter. Okay, when it is occurred means when the noise in the form of pepper noise. When the noise in the form of pepper noise, then only we have to use maxima and the minima filter. So when it is useful means when it is the 100th percentile of the ranked set of numbers is called the maximum filter. 0th is called the minimum filter. Okay, when I am going for the 0th, that is a minimum filter. When I am going for the 100th percentile, that is a maximum filter. So maximum filter is using for when the noise in the form of pepper noise. So what is the equation means f dash of x comma y equal to minimum of g of s comma t. These are the restoration in the presence of noises. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.